In this video, I'll talk about the format of the Advanced Embedded Linux Development course. I'm going to talk about the prerequisites and expectations I have for you as a student covering this course, and also some of the common content regarding assignments and build environments that you'll use in completing the course. And I'll also mention the books that are used as the basis of this course. So talking about my expectations for you as a student, I do expect that you have some working knowledge already of C programming and Makefiles. And ideally, you'd also have a little bit of knowledge of Linux command line and shell scripting. I think if you don't have this knowledge, you're still able to complete this course successfully. It just may take a little bit more time and a little bit more work than if you already had some exposure to these topics. For the assignments in this course, we'll use a Linux-based build environment, and this could be a virtual machine or it could be actual Linux hardware. The assignment 1 document will have some links that talk about the version of Ubuntu Linux that we're currently using for the assignments. And so this will give you some setup ideas and setup instructions about how you can set up your build environment. But there's a few different options you could consider. One is if you have a Windows or a Mac OS main PC, you could use VirtualBox for your build environment. If you do that, you'll want to make sure that you have at least 4 gigs of RAM and 100 gigs of disk space. And again, refer to the assignment 1 setup instructions for any more specific content that's more up to date than this video. But if you are using a virtual machine, you'll need to have roughly double that amount of space available on your host. So if you're using 4 gigs of RAM, you'll probably need about 8 gigs of RAM on your host. And you can also successfully, if you're short on host disk space, you can use a USB 3 hard disk drive or especially a solid state disk for virtual machine images. And that will work as well. Second option is that you can have a dedicated Linux laptop. If you do that, just make sure you find one with at least 8 gigs of RAM and 100 gigabytes of disk space. So the more performant, the faster you'll be able to build your assignments, but it's not a requirement to have a super performant machine to complete this course. So you can think like pawn shops and eBay to come up with something that could work. And if you are going to just pick up an arbitrary system or laptop, it's a good idea to Google whatever hardware module you're picking up and Ubuntu, just to make sure that you can see some indication that it's supported. Typically, most machines these days are supported pretty well, so it's usually not an issue. And then option 3, look for some links in the wiki pages for the assignment-based repository, but another option is to use a cloud-hosted runner, so either AWS or Google Compute as a place that you can host a Linux instance you can use to do your builds. So we'll make extensive use of Git in the course, and you'll turn in assignments through GitHub Classroom. The assignments are going to start with some sample repository content that comes from base repositories. And these base repositories are going to depend on which application we're building and which build tool we're using. But typically an assignment's going to start with a Git merge. And when you do Git merges, there might be an issue. Depending on which files you've modified, you may see Git merge issues. And when you see these, use internet searches to help you figure out the next steps. There's lots of good Git information online. Or use the appropriate help channels for your class. So use Slack channel or use the forum post for help from your peers and from the student facilitators. I also wanted to talk a little bit about the books that I used in this course. I originally based all the content in this course. The first section is based primarily off the Linux System Programming 2nd edition book, which I refer to in some cases by acronym LSP. And this is talking about how the system program is going to interact with the kernel. This is where the processes, threading, and POSIX overview kind of comes from. And part of the first course also covers the Mastering Embedded Linux Programming 2nd edition book. And this has some more of the practical aspects of building embedded systems. And then in the later parts of the course where we talk about driver development, this will get into the content from Linux Device Drivers 3rd edition. And this is all about theory practice related to developing device drivers. None of these books are required to complete the course. This is all background material that you can reference based on slide content.